Hello everyone, my name is Vinit Changala and I am a student of BE in Computer Science and Engineering at RNG Patel Institute of Technology. I am here to represent my task 4 of deep learning of iStep program by StarTech Academy, which is to detect osteoarthritis is present or not in a given X-ray image. As we can see in this image, osteoarthritis condition is in which the natural cushioning is not present between the joints. And in above image, you can see there is a natural cushioning between the joints. So we can say that this is a normal condition. For this detection, we have given dataset which contain three folders: test images, train images, and validation images. And each of these folder has two subfolders: normal and osteoarthritis. Now my task is to create a deep learning model that can provide the probability of osteoarthritis for a given knee X-ray image. And dataset link is also given over here. Now this is my GitHub repository where you can find many other projects, and this is our osteoarthritis classification or a detection repo. In Readme file, I have explained what is osteoarthritis and given the dataset link also. Now further, the solution to this task is, first I have imported all the necessary libraries like TensorFlow, Keras from TensorFlow, NumPy, Pandas, CV2. Now for further, uh, all the dataset folders I have given path to a variable: train path, test path, and validation path. And now I have done a pre-processing, as this dataset contains images of different sizes. So first we have to resize all the images of equal sizes, and I have resized it by 80 cross 80, and uh, all the images of training, testing, and validation dataset. Then I have convert that images into an array using np.array, and then I have divided that array by 255. This means that I have normalized the values of array between 0 to 1. Now further, I have used image data generator to generate images of in test, train, and validation dataset. And further, then I have passed that train data gen to the flow from directory method, which goes through subfolders of training dataset, that is normal and osteoarthritis, and uh, and will give the output as this much image has been found belonging to two classes. And I have done this for testing and validation dataset also. Then I have print the classes of training set, that is normal. 0 is for normal and 1 index is for osteoarthritis. Now I have print the shape of all training, testing, and validation dataset. Now here the pre-processing is done. Now next step is to train the model. I am using transfer learning method to train this deep learning model, and in that I am using Dataset 201, which is very efficient in training this type of images. Uh, in Dataset 201, I have given parameter of input size of 80 by 80, as we have resized all our images 80 by 80 in pre-processing. And I have given weights as ImageNet and include top equal to false. Now here this means that I don't want to train the DenseNet layer that is DenseNet layer has a pre-trained layers, so I don't want to train that layers. Then further I have flattened the DenseNet output. Means DenseNet is a CNN model, pre-trained CNN model. I have taken that output and flattened it and stored that in a X variable. Then further I have added dropout, which avoid overfitting in our model. And then I have given a dense layer, uh, which I have used activation function as sigmoid, as our problem is of a binary class. If it is of multi-class, then I will be using softmax. Now further, I have taken DenseNet input as an input to model, and our prediction, this prediction means this last layer, as an output to our model, and I have stored all this in a model variable. Now further I have print the structure of our model, which is over here. As you can see, this whole is the DenseNet 201 model. We have just edited the model. We have just edited the last 3 layers of our model, which are over here. As you can see, flatten, dropout layer, and dense layer. Now I am compiling the model with loss function as a sparse categorical cross entropy, and optimizer as Adam, and matrix as accuracy. Adam optimizer helps in adaptive learning rate, means it will adapt learning rate as per the model trained. So it is a very good optimizer. Now further I have taken the module like model checkpoint, early stopping, and CSV logger from TensorFlow Keras callbacks. Model checkpoint will monitor validation accuracy at each epoch, and if the validation accuracy is better than the previous any of the epoch, then it will save its weights to this path, and this CSV logger will save all our data in an Excel file at this path. Then further I have feed the model, and give that model to the variable history. In fitting, I have given train X and our train Y, and validation data as val X and val Y. I have given 50 epochs and batch size of 16. After 50 epochs, I have plotted the accuracy and loss line chart. Here we can see the training accuracy and validation accuracy chart, and here we can see training loss and validation loss chart. Now here I have print the loss and accuracy of our model by passing test data to our model, and after evaluation it gives 90% accuracy, which is quite good. Now further my task is to predict the probability of the image that it is osteoarthritis or not. So I have randomly taken 4 images from the test datasets, and I have stored in this folder. Now I have pre-processed that 4 images, as we have to give model a pre-processed image. Then it will predict the probability. Here we can see the result of all four images. The first image probability we can see, zeroth index has a probability greater than 0.5, means it is of normal condition. The image is of normal condition. Similar goes for the second image. Now for the third image and fourth image, we can see the probability of our first index is greater than 0.5. So it is of osteoarthritis condition. So here I have predict the probability of images. Now I have saved that model and print the classification report and confusion matrix using sklearn.matrix. Here we can see this is our classification report and this is our confusion matrix. Thank you guys.